Remember the breathtaking amount of time it took for a supermassive black hole to evaporate? That's a brief moment in comparison to what's going on here. The difference between a second and trillions of years has lost all meaning. Over a time so absurd that it has no name, nuclei keep fusing into heavier elements. Until, when silicon nuclei fuse, they form nickel-56. Nickel-56 is radioactive, which means it's unstable. And when it eventually decays and turns into iron, it emits two positrons, antimatter electrons. And these two positrons find two electrons and annihilate them and themselves. Which is a problem. Remember how the uncomfortable electrons produce the pressure to hold the star together. Destroying the electron means fewer friends to help them hold up the star. Losing an electron does not give them more space to scratch their butts, it just makes gravity squeeze harder, the walls closing in on those that remain. In the case of the most massive black dwarfs, this is catastrophic. Bit by bit, the black dwarf turns into a sphere of iron and more electrons are annihilated. For at least 10 to the power of 1,000 years, almost but not quite forever, there's no visible change in the entire universe. And then, finally, the last thing to ever happen happens. The black dwarf has lost one too many electrons. It can no longer support its immense mass and goes into an uncontrolled collapse, a supernova. It first implodes and then explodes as bright as a galaxy and fills the empty universe with light again. A beautiful moment nobody will get to enjoy. And then, as quickly as it began, it's all over. Darkness again. Emptiness.